A very warm good evening to all tech geeks present here,
I'm Arihant,
and I, Kratika.
and we both welcome you all to this enlightening tech talk. We are glad to announce Mr. Gagandeep Reehal as our keynote speaker for today. He is going to give us some actionable ideas about autonomous cars, and he is also going to share his knowledge and enhance our mental horizon.
Mr. Reehal is the present CEO of a startup Minus Zero, which emphasizes on developing self-driving electric cars in India. Hand in hand, he is currently pursuing his Btech in computer sciences from Thapar Institute of Technology, Patiala, and has been contributing as deep tech engineer in AI research, autonomous vehicles, robotics, and high-performance computing.
He also has specialization in advanced machine learning, self-driving cars, and deep learning.
The age where people are stuck in social media, he has dedicated to stepping ahead and pursuing his dream. He is currently advisor and research scientist at Gen AI Fermi Center for Applied Sciences.
Mr. Reehal has mentored and judged several hacking events worldwide and spoken at leading conferences.
Sir, we convey the gratitude on behalf of all of us to spare time for us and mark your presence. We hope this tech talk would be enjoyable and fruitful for all of us.
Let's welcome Mr. Gagandeep Reehal. Thank you, sir, for joining us today. We would now request you to switch over and enlighten us with your words of wisdom and technical expertise. Please, sir.
Good evening, everyone. So great. Thank you for invitation. I hope you guys will enjoy a lot today. So welcome to Self-Driving Cars 101. So today we'll breaking down the very gist of how all the self-driving cars work for both coders and non-coders. So do even if you're new to coding, this talk is for you. Because see, self-driving cars is a very vast topic. So we can't cover everything in detail, but we'll try to touch every topic that is actually incorporated in development of autonomous vehicles. So welcome to Self-Driving Car 101. So, as I guess the teammates have already introduced me, so I will just skip that part. So, basically, at Minus Zero, we are building India's first fully self-driving electric cars, right? So let's try to understand what makes up a driving task when we drive a car. Obviously, first one is lateral control, that is you steer right or left. Second one is longitudinal control. You brake, you accelerate to decrease, increase the speed, right? Third one comes as object detection and your response to that, or anything like there's a speed breaker, what are you going to respond accordingly, right? Then comes planning, which includes two types of planning. One is long term. Let's say we are going from uh, Delhi to Jalandhar or Delhi to Bombay, which highway we are going to use, will be a major task, right? Then comes short term planning. What it includes, basically, let's say you at a certain path, you get that there is a construction going on that you can't get the idea of in, let's say, Google Maps. So that time you have to plan instantaneously, is there any alternative task or alternative route that you can take. And final comes miscellaneous, because that is the very gist of driving. Anything can happen on road, right? So before we dive further, let's understand what are the basically level. You must have heard like Tesla is doing level 3 autonomy, Waymo is trying to do level 5 autonomy and all this. So how do we define that, right? We define the autonomy level in 5 levels basically. First one being everything is controlled by a human, right? We can call that, or maybe let's say, which includes ADS system 1, 2, 3, basically level 1, 2, 3, 2 and 3 includes ADS system and adaptive cruise control. What they do, let's say they can change lanes for you on a highway, or they can slow down. Basically, you still require human supervision and a human to take over if in any case something happens. Like they are just to assist the drivers. Let's say if certain time driver becomes drunkard and he's feeling sleepy, at that time the vehicle can take off over the vehicle. The software can take over the vehicle for a small amount of time, let's say for 10 seconds or something. And after that comes level 4 and 5. Level 4 is where everything is being done by the like computer, but still you need a human driver to sit at the seat to supervise, right? And level 5 is full autonomy. No matter what kind of scenario you give, you are riding in a desert, you are riding on a, let's say, on a road, or you are just riding in mountains, the software should be able to control all aspects of vehicle no matter whatever happens, right? So yeah, so basically what comes as challenges, why self-driving car is a building self-driving car is a very difficult topic. See, number one, your segmentation and, let's say, detection, object detection, that is a very simple task. That should be robust enough so that you do not miss out anything. Let's say normally if you train a AI data set, like model on foreign data set, in foreign countries there are no auto rickshaws, let's say. So that might, you might not be able to detect auto rickshaws on in the road. So that thing has to be very robust. Whatever you can expect on road, you should be able to detect it. Then comes sensor uncertainty. It includes latency. Let's say the camera is getting the video input, and it is taking, let's say, a few milliseconds to go into the vehicle and then process it, right? And at some time sensor might fail. So our system should be robust enough so that the other sensors can safely steer a vehicle to a certain safe point. Then comes occlusion and reflection, right? Let's say there is a road in front of you, but that is being blocked by some other vehicle. You are not able to see any road ahead of you. How are you going to drive after that, right? Then comes illumination lens flare. That is a common symptom that you see when, let's say, you go into light from a sudden darkness. There's a glare in your eyes, right? And final comes, obviously there is a rough weather, precipitation, and like whatever happens, like say there is rain. So the system should be detect in that kind of scenario also, right? So first comes, there are two types of thing. Like I'll just give you a brief overview. We, for self-driving, we have two approaches. One is end-to-end approach. What is that? That you put a like camera feed into a neural network, and it gives output as, let's say, steering angle and the, let's say, the speed of the vehicle. But that is not robust. That needs a lot of data to train on, and if in case there is certain unseen data, it has higher chances of fail. So the techniques that we at minus zero, or even companies like Tesla are using, they divide the whole autonomy, basically automation of the vehicle, into subtasks. Let's say lane detection, one subtask; object detection, second subtask; motion planning, third subtask. And all those subtasks are merged into one to, like, steer the system. So first comes the reactive planning. What do we do in that? There is a certain object, like we get a certain stimulus and we react to that. Let's say there is a dog in front of our car, and we react to that by stopping the car. That is called reactive planning, when you react to a certain situation instantaneously. Second comes predictive planning. What is that? You predict the path. Let's say, where are you going to do, like, you have to take, like, say you have to take the bypass road, or you have to go through the city itself. That is predictive. You have to predict which will be the best way to follow. Or even if you're going on a vehicle, you have to predict, let's say there is a vehicle in front of you that is slowing down, or it is giving an indicator. So you predict that in most of the cases the vehicle might stop or take a right turn or left turn. That is prediction, right? So basically, the software architecture on a higher level is, you have a certain sensor output, they give output, and using that, you do two things. One thing, you perceive the environment. You know what are the things, like there is a man in front of me, there is a car in front of me, you detect all these things. That is called environment perception. And second comes environment mapping. You create a virtual map, like a 3D map, which you might have seen if you are in robotics. I guess you must have used simulators like Gazebo. What they do, like if you take basically radar outputs, you create a point cloud map. What object is at which part in the 3D environment around you, right? That is environment mapping. And using those outputs, you do a motion planning, right? You plan a motion, then it is given to controller. That can be basically a microcontroller, which gives signal to the actuator. Here actuators might be motors to steer the vehicle, sudden, let's say, horn, that are actuators, right? So what are environment maps? There are basically three types of environment maps that we use for self-driving car. One is a localization of vehicle that you get from a sensor like lidar, point cloud, which you can see in the top right corner. That it detects, like, wherever there is an object, it points that out in the simulator, that okay, in the basically environment 3D map, that there is an object here, right? Next comes basically path planning maps that are basically similar to how what we use in Google Maps, that you have to plan a path, which roads you have to follow. They are mostly, it is measured in terms of a graph. You have also used data structures. It is much similar to that, right? And finally comes that is what we call occupancy grid map. What they do, they have a certain camera feed, and they divide it into number of block, let's say x by y, x columns and y uh, rows, and you assign each pixel, each block, whether it is occupied or is it free. Like if it is free, you can move on to that path. If it's not free, you have to not, like, you have to ignore that part. Similar to how you can see that there are certain blocks which are filled as occupied and there are certain which are free, right? Then comes sensor. We have like a lot of sensors that we use: cameras, lidars, radars, ultrasonic, and all. But there is one difference, that is, see, companies like Waymo or let's say Argo AI, what they're doing, they are using they make heavy use of lidars, and lidars are very costly sensors that make self-driving tasks very costly and cars very costly. And the difference between companies like Tesla minus zero and companies like Waymo Argo is that companies like Tesla focus on using on the only camera outputs to the most, like similar to how we humans drive. We use only eyes. We do not actually need to measure the exact depth of an object in front of it. We do it through approximation with our eyes only, right? So, and after that comes waste. You have to plan a path wherever the sensor is installed. You have to know that to perform a certain maneuver, let's say you have to overtake, you have, for overtaking, you need to have a vision of a certain perspective. Each camera has a view angle, right? So according to that, you need to know what kind of coverage you require for each maneuver, let's say for overtaking or something. So that thing has to be planned before, right? So this is just a basic what you call a simple architecture that Waymo is using for its self-driving vehicle, right? Then the comes most important part, that is a self-driving brain, that is basically the processing unit. Now the thing that has to be noted is that, let, if you are a very gaming geek, you might have seen your GPUs getting overclocked, right? When you're playing a game on high FPS, your computer generates a lot and lot of heat, right? And you require a lot of power. But the thing is, on a car, you have limited amount of power. You have a limited amount of battery that has to both drive a vehicle in case of electric car and power the brain or the sensor also. And thing is, the more heavy the AI model is, the capacity of the AI model is measured in GFLOPS, GFLOPS, giga floating point operations per second. And the more heavier the model is, it has to perform more and more operations, because after all, a computer knows only two things: zero and one. So it has to perform a lot of those operations over and over again. And the bigger the model is, the more higher advanced basically the power your computer might need. So you have to keep that in mind, that your system has to be computationally efficient. It should consume less power, let's compute, let's say less RAM memory, less GPU memory to compute. Let's say even the best, like topmost semantic segmentation algorithms take around 1 second to process a single frame. But on a computer, in a self-driving car, you need to do that instantaneously. So that means your system has to be very computationally efficient, right? And we define to basically define various safety levels. Example for used by Waymo, number one is behavior safety, whether the car reacts properly. Let's say there is a woman in front of the car and there is a small kid, it should know that has to react differently, right? Then comes functional safety. Functional safety includes, okay, the sensor should not fail in any case, right? That is thing. Crash safety: if the car crashes, whose mistake would it be? Like, let's say the self-driving car crashes in a certain scenario, who is liable? Is it the mistake of the car manufacturer? Is it the mistake of the person who is owning the vehicle while he's not driving it, the car was driving autonomously? Or is it the mistake of, let's say, the government who passed the regulations or who approved that car to be complied enough to run on road, right? Then comes non-collision safety and operational safety. Those are very simple, right? So if you I will not go into everything, because for every concept in self-driving cars there is a lot of mathematics that goes behind that, and it is not possible to cover that in a 1 hour. Basically you need to study for at least, it will take around 10 to 20 hours to just cover all the basic details of the mathematics going behind in depth. So let's say the simple, to make it simple, if you must remember your, let's say, class 11th mechanics, we use things like free body diagram and all, right? We, instead of considering, let's say there is a very dynamic object, we consider it as a single point object. In case of a vehicle, we consider it that instead of having four wheels, which will involve a lot of calculation, we make it simple. Let's consider the cycle to be a bicycle model. Like instead of last two wheels, we replace that by one, and even in place of front two wheels, we also replace that by one, and we have this kind of bicycle model. And you simply have, you have angle, beat, and all, the similar to how you did in basically mechanics in class 11. That simple process is followed to actually get the basically estimation of the vehicle, right? Then comes longitudinal vehicle model, that which includes all the factors like the friction in the front and rear tires, the aerodynamic drag, the resistance by the road, and the gravitational inclination to find the max vehicle acceleration. And then, as I said before, that is simple dynamic modeling we use. We coordinate the frames, we lump all the dynamic elements, we create a free body diagram, and using all those dynamic equations that you create from the free body diagram for all the forces, you just equate them and you get the certain state of the vehicle. So this is not a rocket science. The every logic that you use in building something very difficult has is simplistic, quite simplistic. It's just called what we call first principle thinking. You break the problem down to its very foundation, and you just try to solve it using that. There are no, like, this is, there is no rocket science that goes behind self-driving cars, right? Then comes another thing that we use, that is called combined feed forward and feedback controller. If I would put it in a simpler way, how cars work is that it takes a certain step, let's say, uh, turn the angle 10 degrees right, and then sees the camera has it taken the right decision. It gets feedback from the camera or sensor that okay, the car has taken right decision. Then it's okay. If the sensor gives the car has not taken right decision, then again it iterates. It's keep on iterating. It gives the output, it gets feedback, checks if it's right, then okay. If it's wrong, then it's keep on iterating in that cycle. And that is how you create a real-time environment, real-time system, right? Then comes various controllers that you are used to control a car. And you might have used controllers like lead lag controller and PID controller in even in robotic cars that you make at home, or even using drones. But to consider basically complex uh, scenarios that you can find in traffic, we use other geometric controllers like Stanley controller, or various non methods like backstepping and all, right? So there is a lot of mathematics that goes behind these methods. You can just see those, and later on, if you find interest in that, you can Google it out and try to study all the mathematics that goes behind that. But if you're studying robotics, you might have come across many of these algorithms while working on the things, right? So, and then we have various kind of loss functions that we use to calculate whether our vehicle is doing the right thing or not. The simple example is of simple loss function could be the distance between the to ground truth and the expected predicted output. And to actually increase their efficiency and insight you can gain from the loss function, you can use various like weighted least squares, recursive least squares, and maximum likelihood situations. Again, as I said, these all have a lot of mathematics that goes behind, and you can always Google them out and get them out. One thing that we use that is very highly dominating in self-driving industry is what we call Kalman filter. So the base very if I had to put it in simple ways, what Kalman filter does is normally the controller would uh, make a give a certain actuation and then optimize it. But what a Kalman filter does, it gives a certain prediction, and using the sensor outputs, it actually fine tunes that prediction. That okay, the sensor gives prediction that the angle that you have to turn might be 10 to 12, and the using the sensor outputs, you actually fine tune it that okay, it's 11.5, and you do that. That makes it unbiased and consistent. And we you can always Google it out, and this is something algorithm we use in that's called blue, best linear unbiased estimator, right? Then, as you know, obviously we have some common things that you find in even everyday mobile phones, satellite navigation system, right? differential navigation, and then inertial measurement units, which includes magnetometer, and accelerometer, and gyroscope that basically maintains the calculates the vehicle's acceleration and all, right? Then comes lidar, which currently are the most costly sensors that are used in a vehicle, and that is what the industry is trying to overcome. Because to make self-driving cars more cost effective, they are trying to decrease the use of lidars and make more use of cameras and all to detect that, right? And what lidar does, it is simply similar to radar. It sends a laser beam out, and the time in which laser beam returns, it calculates a certain distance, and it marks a certain point that, okay, at this distance there is a certain obstacle. And with a lot of points like this, it creates a point cloud that you can see in this picture also, that it creates a point cloud of the tree, let's say, right? And there are various algorithms that we use basically to actually fine tune the lidar data, that is iterative closing point algorithms, right? So this is similar, one of the simple examples of how an lidar map might look, right? Okay. Then comes one important task that we have to make sure in self-driving car is calibration. See, the software will give a certain output, okay, turn left or turn right 90-degree. But to actuate that in real life, if you are using a, let's say, gear mechanism, to turn the main gear 10 degrees, you might have to rotate the smaller gear 10 times, 10 rotations to make the bigger gear turn 10-degree only. So that is calibration that you have to do. That depends on the hardware. So this is one of the point that you have to focus on. Self-driving car is not a software problem. It is a software plus hardware problem. Currently at -0, we are building self-driving cars. I'm telling you from a personal experience. You might make the whole software that can work, but if you say that there is a 50% role of software only, and other 50% role is of hardware, you have to make sure your sensors do not have any latency, your processing does not have any latency, because that will decrease the basically accuracy, right? Then comes intrinsic calibration, that is, you have to know the basically, what a simple example would be, zero error and all, right? Then comes extrinsic calibration, that is that you have to calibrate that, okay, every sensor is not at a single place. Lidar might be on the top of the vehicle, camera might be on the bonnet, certain sensor might be on the rear wheel. So you have to take into account that there is a big distance, there is a certain distance between the vehicles, and you have to take that into account while predicting. And last comes temporal calibration, that is basically the time latency, right? One thing more, you have to make sure you have multiple sensors, because there are many chances that a certain sensor might fail, and you have to make sure the other sensors, let's say there are 5 sensors in a vehicle, if one fails, the fourth should be capable enough to safely steer a vehicle for a certain amount of point before a backup help comes or something like that, right? And again, one thing you can look for is something we call uses extended Kalman filter. As I said, it uses IMU, inertial measurement unit, GPS and lidars to actually compute what it propagates a certain prediction, and it computes the error, then it removes that error and gives a fine-tuned prediction. So this is very important topic, right? Then comes visual odometry, simple algorithms which you use, like the things are very common, like let's say the object detection segmentation, that is common. Another thing we use is, like, instead of using lidars to calculate the depth, we use stereo cameras, right? You have two outputs, like you have two cameras that are placed adjacent to each other. You take a picture of the same frame, right? And you compute the distance between, let's say you match the features, and you make note what is the change between the linear change between those features in two concurrent images, and using that you can get us basically depth using stereo vision, right? There are various feature detection algorithms that we use, basically Harris Laplace, right? And differential of Gaussian, and you can easily get it. Most of these are available as a pre-built features in OpenCV library. So what feature detection, basically does is that there are certain features in an image that you can get, that can be edges of a certain thing. Other feature can be, let's say there are two concurrent images, and you have to detect that the 2 points, let's say point A in one image and point B in two image, they are the same point. You have to find the same. These are all the features that you can incorporate, right? Simple example is that you can just see here they have used brute force matcher that is available in OpenCV library. So it simply you have two concurrent images and it tries to find which parts of the images are same. See, the reality is computer does not know what an image is. What is known, it will convert the image into three channels RGB, and for each pixel it has a certain integer value. So what the computer understands is basically matrix, and matrix is converted into a binary unit. So that thing has to be kept in mind, right? So then again, we use coordinates, which include the simple, let's say, 3D object detection, 2D object detection, and then comes segmentation. Segmentation is the divide, allotting a certain class to each pixel. Like, okay, this pixel is road, this pixel is man, which is you can see on the right hand side image. And object detection, you might have already seen a lot of times, right? Then comes various neural net physics, object classification, object detection, depth estimation, semantic segmentation. And these are things that you will learn if you're studying AI. These are things that we will learn in the very initial beginning also, right? uh, I think we have already covered these things. And then yeah, and then one more thing, there are various features we use, like that in semantic segmentation, that instead of you have a camera feed of 4K, basically video feed, let's 4K, or let's say 1080 pixels, 1080 by 1920. So this much big amount, just imagine how many uh, values are there. There are three layers of image, colored image, RGB. So just imagine 1920 into 1080 into 3, such a big amount of values, integer values, you can find in just one single image. So just imagine how will computer format. Usually our videos are at a frame rate of 30 fps or 40 fps. So what you do is something we called doing downsampling and upsampling. What we do, using convolution neural nets, we downsample that image to a, let's say, a tensor of we can say 360 by 360, and extract those feature, and then upsample it. That is, you reduce the resolution, find the features, and increase the resolution again. That is to increase the efficiency and speed of the vehicle, right? Then comes 3D tribal surface estimation, that is done using a RANSAC algorithm. What you do is that simple, it's very simple. You can search it out on Google, and you can know it's basically uh, gives out a 3D plane as an output. Okay, this is the place that where we can drive. You get 3 points, right? Using least square estimation, you compute these three model parameters, and you compute number of inliners, right? And you check whether the inliners are over a certain threshold, otherwise go to slip. Basically it's like you are checking each pixel, and you are getting a certain uh, what you call plane, basically equation of a plane as an output. See, this thing might seem very complicated at the beginning, but I'm also at the loss here because it is not possible, because there's a lot of mathematics going by, so it's not possible to understand all that in, like, say, a 1 hour duration. So if you're interested, do search for these kind of things in Google, RANSAC algorithms and all, right? Then comes semantic segmentation. In that, again, there comes one thing we commonly use in foreign countries that is much incorporated is lane detection. What you do is, using a canny edge detection, you detect the edges in a lane. You put a certain threshold, like let's say a Gaussian blur, to remove the outliers, and you get the most prominent point of the edges, right? And then using Hawk transform or other algorithms like that, you like put a basically line, you compute a line that is detect or syncing with all the marking of the lanes. But this thing can't be used in on Indian roads, because you really do not find lane markings on Indian roads, right? So yeah, that is the thing. Like, next comes hierarchical planning. We drive the vehicle task like into, that is the very feature of multitask learning. You first plan the mission, using its outputs you plan the behavior at instantaneously. Then at the next, you plan locally, like what path you have to follow and what velocity you have to get, and then finally you control. You do it step by step. There is nothing, this is a very big myth that you take, like you take one, you make a one big AI model, and you put a camera feed into it, and it gives out output. This is not, you can't solve big problems with a black box approach. This is what is black box approach, that you do not know what processes is going behind the model. You just know that there is some input and some output. You do not know what processing is going on. That way, this thing is quite vague, right? You have to train it on lot of data, and if there comes any unseen data, your sensor might fail. So that thing has to be computed, right? Okay. Okay, then comes behavior planning, which are kind of rule based systems which you put in. That can be, if there is a green light, you have to move. If there's a red light, you have to stop, and all that. And one thing we often use in that is called reinforcement learning, that we have a certain pre-trained, let's say, model, and to increase its efficiency, we use a concept called reinforcement learning. What is that? Uh, you do a certain task, let's say car drives, and if it makes the right decision, you give it a reward. If it makes a wrong decision, you give it a penalty. It's similar to what you find in like home. If you do a mistake, your mother might slap you. If you do a good thing, you make do like have good habit, your mother might reward you with let's say a toffee or something. So what our mind is, we will try to maximize the rewards. We'll try to maximize getting toffees and chocolates. That is how also computer is. Once you are get computer knows, computer also always try to get, let's say, maximum reward. So whenever the algorithm will penalize him for doing something wrong, it will try not to repeat it again, right? Then comes the lattice planner, which use you drive, let's say there is a straight path and there's an obstacle in front of you, and basically you divide your path into multiple tree, like tree into a subtree, then again subtree, then again subtree, and you compute. This is similar to a graph, and you compute the most smoothest curve that you can go on, right, using the Dijkstra's or A stars. These are called lattice planners. And then you also have to make sure the controller that you are using, it's smooth, if there is any deviation from the main path, you basically optimize that and make it normal again, right, and all that. Another come there concepts like lane rate connectivity, right? And then comes there are certain equations with which you can actually smoothen down the curve that you will be following while driving. You do not have to take a sharp turn. That will be very like, or you have to make a smooth drive. You have to put in the accelerator slowly, and you have to brake also slowly. No one likes driving in a jerking car, right? That will be dancing cars. No one wants that, right? Okay. We have already covered mission planning, and then there are certain, let's say, assumptions which can improve predictions. That can be that you make a certain use of heuristics, like let's say that in most of the cases, if the vehicle in front of us has to change lane, it might give a signal. So you use this what we call jugaad. You make these assumptions that if a vehicle is slowing down, then it might stop. If vehicle is giving a right indicator, it might turn on the next road, right? So that is the thing that you can basically, you have to assume to make you fine tune your predictions, right? I guess that's it. Then there are various algorithms you can use for, let's say, basically collision detection. You can consider your vehicle as a subset of various circles, and you try to compute whether the circles collide or not. You can just after that, I guess this talk will be recorded, so you can just pause this slide and then you can read the equations. So it's quite simple, right? We'll not cover that now, but you can always pause this slide and read those, right? And then there are finite state machines. What they are, they're kind of rule based system. Okay, if the vehicle is below a certain threshold speed, you can increase it. If it goes too much high, you decrease it. If it remains stable, you keep your algorithm stable. So that is something. If there is increase, you make it right again. If there is decrease, you make it right again. Like you have to maintain your speed at a certain basically right level. So I guess that's it. And then if you would like to follow basically research on autonomous vehicles, you can follow many, like there's much research going on at MIT, right? And then NVIDIA Drive, that is a neutral competitor. Uber tried to do self-driving cars, but it actually dumped it self-driving project, and currently it's not focusing on that. And then we have major competitors like Waymo, let's say, and Waymo basically focuses on end-to-end driving. And then comes the global player, the big gold Elon Musk himself in Tesla, right? And there are many. There are companies like Argo AI, and then companies like Comma AI. Comma AI is basically making ADS system for that can be installed in certain vehicles. So like there are a lot of companies. And in India, we also have our own startup Minus Zero that is working on building self-driving cars, and plans to launch fully self-driving electric cars by for Indian traffic by 2023. And one thing that we have to really emphasize on is that in India traffic is quite disorganized and unstructured. You can't assume that people will follow rules. Anything can happen on Indian road. Anything can come in between. There are motorcyclists and all who will try to overtake in very complex maneuvers, right? So that thing is adds an additional burden on the self-driving infrastructure, which is really important to make achieve self-driving level 5 autonomy, right? I guess that's pretty much it from my side. We can end here and have the questions. I know this lecture might be quite slow, but the thing is, there is a lot of mathematics that you can't cover in a duration of half an hour or 1 hour. So you have to study that mathematics a lot, right? So that is something. So do try to look about these things on Google, and you will get a lot of materials. I'm telling you, much of the material about autonomous driving, except that is like what do you call secrets of, let's say, Tesla or like company like us. Most of the thing is available as an open source. You can always go through those. I guess that's it. So yeah.
Some questions which you might be answering.
So,
Sir, I would start.
first question was from a guy. He asked, "Can self-driving vehicles be solely dependent on electricity, or we can use them on conventional fuel?"
See, I'll give you a very simple example. In a conventional internal combustion car, simple thing is you have to manually switch gear, right? You have to press clutch, and that is something that you learn by intuition. Whenever you drove the car first time, did you made it? You release the clutch at the right time the first time. There is a certain pace, and at different speeds while changing gear, you have to release clutch at the in different speeds. So that thing can be solved by, let's say, automatic transmission vehicle. But thing is, in a fuel vehicle, the preciseness is little bit difficult. See, in a electric vehicle, everything is controlled. We use induction motor, simple, let's say, IPM sin RM motor. So what is that? To control the speed of the motor, you change the velocity of the accelerating current, the frequency of the accelerating current. Like it's at a constant speed at 50 hertz, it will change into other speed at 60 hertz. So that thing you can do very precisely. While in fuel vehicles, you have to do it with a certain approximation. So electric cars are beneficial if that are beneficial to add to the safety, because that is thing. Why would anyone like to drive in a self-driving car that is not safe? Because see, if I'm
Yes,
asking you, are you ready to drive in a, I'll see what I'll do is I will make an e-rickshaw drive without a human. Will you be, there is a certain fear that comes in you, yeah? Will computer do the make the right decision? So safety is more important than technology in self-driving cars industry. And that thing is, and Waymo released a basically safety, basically a 80-page safety rule book, how self-driving cars need to be made safe. Like more bigger than the code base of self-driving car is the basically the documentation of the how safety can be incorporated. So that is the thing. But yeah, we can use conventional vehicles, but we have to switch to electric vehicles at some point or other in future. So why not now? When we are embracing a
Yes,
new technology, let's switch to that, right?
yes, sir.
so we would be very eager to know about your journey with minus zero. What were the motivations behind it, and who were the people
So,
who supported you over this?
Basically, see, it's something quite difficult in India, and the first thing we got whenever that we are doing, trying to. Who is Just Jot?
Maybe just Joseph, a fellow mate, I think is.
Okay. So basically, let's say like this was something really tricky. Like everyone was like, "Are you? Do you really think these things like this could work in India? You know the traffic in India. There are people who will just stop the car anywhere and come out hurling, let's say, abuses as other person if there is certain catch. Like that is anything can happen on Indian roads. You can't. There are no lane markings. There is construction going on at some place or other. So that was something very difficult but tricky. But we hopefully, and in a couple of days or maybe by next week, we are actually putting out a e-rickshaw that is being driven driverlessly on a public road, and that is something that I think first company in the whole world might be doing, directly putting something out on
Congratulations, sir.
an Indian road. And but yeah, the thing is, obviously the path is very long. It We have like the estimated launches in around 2023. It's a long process. Lot of work is that needs to be done.
Sir, as
So I
an
have a again.
uh, sir, as an entrepreneur, sir, what are your views on taking up the big companies like Tesla is coming to India and
Okay. One thing that is the biggest drawback in India is the Indian industry. Like, which stream of engineering you are from?
so electronics and communication?
Okay. And Kritika, you?
So computer science and engineering.
Okay. What is the reason that you do not like, let's say, see, Indian ecosystem, let's say, even in startup and even as a multinational companies also, Indian ecosystem is dominated by service-based startups or service-based companies. Like, let's say at one point, or maybe you can say Wipro, Infosys, and due to that, they pay very less. Most of the engineer are getting 5 lakhs, some like a package, and this thing you have to overcome, like, because service-based startups or service-based companies can easily make money quickly. But if you say product based companies, let's say something that is being done in a new way, let's say there's a space startup by Skyroot Aerospace, if you have heard, there's a startup Pixel, and let's say there is self-driving car. Before you can actually get money from consumers, you can start generating profit. You have to burn cash, much cash continuously for 3 or 4 years into research. And that is something people are not ready to take in India. That is why this is one of the major problems, because these product based companies can be quite capital intensive. If you say, let's say I'm doing a space startup, you need a lot of money to do that. And in India, this is the only drawback I find, that let's say even investors or even the people, they try to do something that can be done quickly. They work on corporate business model. We already had Amazon, Flipkart, and okay, then we started Mantra, Jabong, and the line goes on. We already had, let's say, Coursera, edX, then we came Baidu, Vedantu, and like we take certain things and keep on replicating that. So that is a thing that needs to be worked on by like Indian entrepreneurs a lot. I always believe that.
Perception needs to change, sir, from
Yeah,
the
that is the
uh,
thing, because you cannot make India a global technology leader using service-based startups or
yes,
service-based companies. You have to go into productive. And if we have productive companies, you obviously each engineer would get a really good package. In
yes,
service-based companies, you only have to do the work like debugging and something, what you call the boring corporate work. And in product
yes,
based company, you will actually learn, like simple example is, you would as an electronic engineer, you would always want to work in place like ISRO, or let's say
mm,
a place like
DRDO.
Intel or Nvidia. You will not like to work in a service based company, because you want to contribute to something new. And obviously when engineers are doing something new, they will obviously you will get more money. But only thing is, you have to little burn a little bit cash. Tesla took 10 years to become profitable.
Yes, sir.
Amazon took around 30 years to become profitable, basically. And like
Yes,
companies like Swiggy, they are still in loss. If you say the amount of investment they have taken from investors and the amount of revenue they've generated from users, simple example, like business model has to be really good. If you say the see if I talk in terms of Swiggy, the shop owner which is providing you the food, he's getting the exact amount of food. He's not providing you discount. The discount is being borne by the Swiggy. So the kind of Swiggy is already giving you so much discount, Zomato is already giving you so much discounts, and the company is going as loss. That is the thing. Yet they take too much money from investor, but but they are not able to generate that much revenue. Obviously every time you order something from Swiggy, you get 30% off guaranteed.
Yes,
This is
yes, sir.
common, and that is a little bit tricky. Like you have to burn a cash a lot, and this is thing, the perception needs to change. You have to get good innovation with a good business model. You can generate money. Maybe you can generate money after 5 years or 10 years, but you have to generate good amount of money. You cannot be consistently be in loss. So these are a couple of points, I guess.
So I have a question. Like, Okay, sir, we'll just read it out. Autonomous cars even carry risk with a little getting hacked, etc. So, do you propose this can be dealt with?
Actually, that is one of the USPs we have. We are at minus zero. Our main USP is AI that is less dependent on data. So we are not collecting any, like normally a company like Waymo has to drive millions of miles to collect video data from the users. But our things is totally standalone. You just have to kind of use a GPS for updating, let's say Google Map or something. But the AI model is totally standalone. You do not need to connect it to on network. Only thing time you have to connect it to a network might be like you park it at a home, you connect it to your Wi-Fi, update the, let's say, the consistent software updates and all. But while working, you do not have to interact with any servers of ours.
So
That
my
is
own
something.
doubt is,
So, it's
sir,
called
my own doubt
dynamic.
is that is everything today is being driven by data, and
Yeah,
data is today the most expensive thing. So, sir, how come you are just skipping that thing that in
okay,
your minus zero? Hmm.
I will give you one. uh, do you show a baby 10,000 images of a bird to make him know that there is a bird in front of him? I'll give you,
No.
you will know. I'll give you one. Let's say you are a baby. I'll give you one image of a bird, and I'll tell you that in most of the cases, bird can fly and has two wings. The baby will be able to know. We do not care about what species a bird is, but we'll be able to know. Okay, this is a bird. There is something that goes in our brain. How much data do we have?
I
Right?
don't know. I don't have an idea about
They like simple. Do you show a baby 10,000 images of a bird to detect a bird?
it.
Because that
No,
is
actually,
something.
we just show the baby the bird, and
One
that
bird.
is yeah.
One
Because
picture
there are
many
certain kind
times.
of features that we inherent biologically. Our mind
Mhm.
works on something what we call intuition, and that is what we are replicating at minus zero. So that is why,
Actually,
and data driven is, see, I always feel there is a big difference between artificial intelligence and data science. They are totally different things, and people mostly confuse that. AI needs not, like, deep learning is just a 10% of the what AI actually is. AI subject, let's say, if you take, right. So there are many things, like there is, if you, I'll give you example. There was a certain HTML language called AIML, artificial intelligence markup language. What it did was it got patterns in a, like, it was released around 20 to 25 years ago. It, like, I don't know exact figure, but lot of time ago it got patterns. Let's say you are a question, what is your name? What it know, it will generate a pattern. Okay, there is a name in this sentence, then maybe the person is asking for a name, I will tell him the name. Where you were born, okay, there is a word born in this, maybe the person is asking my birth date, I'll give him the birth date. So that was also AI. There are rule based systems, there are finite state machines. So deep learning is just one part, 10%. And people mistake that, okay, everything you have to do with deep learning. And even neural network, there was one paper that was titled neural circuit policies for auditable autonomy, right? There's a GitHub repo also named keras ncp. It used 19 neurons to control a thing, unlike the state of art networks, which have like 8 million neurons. So we buy, that is the something,
That's
that is the way we are progressing. This is a progression that we have to go through. This is a part of the process. We start with a lot of data, and then we are slowly trying to decrease the dependency on data. And that is something that we really need to know. Like, currently what AI does is efficiently crams up data.
yes,
Like, what do you know? There is the trigonometry formulas. You might have heard Pandit Badri Prasad Bate Har Har Bole.
Yes, sir.
PBP, right? Now, what you do is you cram that data in a simpler way, but still we are cramming that data, and that is not intelligence. That is something you are just replicating. You cram that data and you
I
rush it.
in my
Spit it out
opinion,
to
I
the.
think the notion that you're following is a 20-30 year ahead notion, because in this global world, sir, governments are protecting data. They're requiring data protection laws, very strong data protection
Right.
laws, And this is
That
a
is
very
thing. I'll
visionary
continue on
approach
this.
I think you have about the
That is like,
minus
do you
zero.
think even for a small thing, WhatsApp changed a certain privacy policy that
Yes,
we
sir.
will share the data with basically not your chats, only your name and phone number with Facebook subsidiaries. And in
Yes,
India,
sir.
people made a lot of fuss. So, do you
Mhm.
think in India will government allow collecting us to collect the data from the
No,
country? People
it's
will actually
yeah.
make a. So that is the thing. This we are trying to solve a problem here because we instead of collecting data, let's try to develop a system that is very less. We are not saying zero dependency on data, but yeah, little dependency compared to thing. That was yeah. We can have another question. I think there are a lot of questions that are in the chat.
We have done this. Can you just
Yeah, we
please
have
move
done
forward?
this.
So, sir, I have a question. Like you talk about AI. So, we all know that India does lag behind in terms of opportunities in AI and deep learning. So, how do you advise an AI enthusiast to go ahead in this domain? Like, if he
Okay.
wants to have his career in India in AI.
Okay.
So,
They one thing. If you target you want to be a ML engineer or deep learning engineer in company like Google, sorry you can't do it or after graduation because in Btech there is one subject AI that is too theoretical, right? Or there can be one subject machine learning. AI is a research subject. It is not a something like you can take a deep learning specialization by Andrew Ng. That's something that everyone has taken, but is that is just 1% of what AI actually is. It's a research field. So normally bigger companies will require you to have at least masters or PhD in AI to actually be pursue this. But try to go for startups because startups usually prefer to take young talent to do that. And there are a lot of startups. There is one very famous Rephrase AI company. What they are doing is that like for using, let's say we have to create a, it's kind of a deep fakes company. We have to, let's say, I don't know the exact business model. They have like wanted like you want to have Shah Rukh Khan in your advertisement, but you can't pay big much amount of money to Shah Rukh Khan. So using deep fakes, you make the deep fake of Shah Rukh Khan and make him advertise your product. So that was something they're using like rephrase.ai. There's company like there are a lot of AI startups that are in India. And just try to research about them on like portals like AngelList. AngelList is a portal that is solely where startups use to recruit talent. So you
yes,
can
sir.
always go through that. And once you have experience, you can always switch to companies like let's say Google or Facebook, which requires because you either have a PhD or masters, or have a lot of research paper published at undergraduate level, or have a lot of work experience. You have to go in one way.
So, sir, what are your plans with minus zero to counter tech giants Tesla who are steadily creeping into the Indian market? Like, how do you curb them and move forward?
One thing that is AI less dependent on data. So we do not need to collect data for 10 years to make our system robust. We
Yes,
plan to
sir.
have level 5 autonomy in India node by 2023 sharp. I'm telling you, we have a demo planned in this end of this month also. Like we are not depending on, we do not need any lane marking to detect road, right? Even the speed of the other vehicles in front of us, we are detecting it from cameras only. Zero use of lidar, zero use of depth sensors. We have around a sensor suite of 8 cameras, right? And I think there was one question also. Someone asked, how many cameras do you recommend? So it depends on the view angle. Every camera has a certain focal length, and there is like a view angle. It camera captures this kind of view, and you have to make sure that it depends on where you place the cameras and what is the specs of your camera, so that you know every point. You have a data of every point. Let's say all the 360 view of around the vehicle. So that depends on the camera specs and your basically orientation where you place the camera. Another thing is affordability. Tesla in India will cost, let's say, Tesla is a supercar. Tesla is a luxury car, not a consumer car. In India, people buy a car that costs around 10 lakhs or something, right? No one goes above that. So that is something we have two advantages over Tesla. But Tesla, see, the thing is, these companies are not our competitors. They are also researching. We are also researching, and actually, things is we all are mutually benefiting from these things. This is not something e-commerce that is totally established. Tesla is also trying to find something new and new methods to do something. And let's say, if I say we are also trying to do that. So we are not competitors. We have the same vision, and we are trying to reach that on our own paths. And it does not matter whichever reaches the position first.
So, sir,
So,
here we
Let's
have the
focus on
question.
innovation, then competition.
Yes, sir. So here's a question like, can the AI of traffic vehicles in a video game be used for autonomous vehicles in real world?
Okay, traffic vehicles in video games. Uh, you play Speed, Need for Speed, or you play Asphalt 9. Do you really think that kind of scenario? See, for self-driving, we have simulators like Carla, AirSim. Even NVIDIA has something called Drive Constellation, named something, right? So there are simulators that are particularly developed for AI. You can't use that game is something that game model will play the game accurately, but not real life. Yeah? You do not fly cars, you do not do stunts in real life. No one does. So that is something quite like unrealistic. But there are certain simulators, and these are open source. Carla and AirSim, you can always check. You feed them inputs through a Python script, and the vehicle you can drive visually. It has all the maps, various traffic scenarios available.
how, being an entrepreneur, how did you end up being a TED speaker and being such a great speaker?
Uh, I was a tech speaker first. I became entrepreneur afterwards.
Okay.
It was opposite way around. Basically, I started with like around from class fifth only. I started participating in hackathons and all, and slowly from participating in hackathons, we started mentoring, and then after mentoring, we converted to like people started inviting me as a judge, and now they invite me as a speaker or something. So yeah, we have to start somewhere. I am not someone like opportunity never comes to you. You have to go to the opportunity yourself. Opportunity never knocks at your door. You have to knock on the door of your opportunity. And
Yes,
once
sir.
you are एक बार engine start हो जाता है, then it goes on smoothly. To start the engine, that is something you have to work. That is a little bit difficult.
India
This
does
is
build.
done. This is done.
So AI does lag behind in terms of opportunity. How would you? I think we have answered
This
this
is
question.
done.
We
Yes,
done
sir.
this.
So there's a question like, I'll just speak it up. Wrong indication is quite common on Indian roads. So how can autonomous vehicles cope with that situation? Like, how do
Do not
you think to?
depend on that. Simple logic, yeah. How a human drives. Do you really think that if a person is giving, even when I drive, sometimes accidentally I might give out my left indicator. That is a human error. So do not depend on those things. No one see. I'll give you a thing. There is a speed limit sign on every road. Put a hand on your heart and tell me, did you drive a vehicle at the speed of 60 in a place where the it was written 60 kilometers per hour?
No, sir.
Like, have
Nobody
you ever
follows.
No, sir.
like have you never overtaken a, let's say, missed a traffic light?
Uh, we
You
very.
have missed, right? There is a rule that you always have to overtake a vehicle from the right side and not from the left side.
Yes, sir.
Have you never overtaken a vehicle from a left side? Yeah, these rules can be followed. That is something. There is a difference between India and foreign countries. That's why self-driving car is tougher in India. Like, this is
Yes.
something you can keep a hand on your heart and think, do we do like this? Is this feasible in India? And I guess that answers most of the questions like these.
Yes, sir.
Rhetorical questions there.
Okay. So what this is a very good question actually. The government is not supporting this idea of a taxi industry as an autonomous, because it will lead to loss of jobs of taxi drivers, right? There will be loss of, but if you talk in terms of company like Ola is a company that is currently at loss because it has to give affordable prices to the consumer who book the ride like us, but still they have to pay the driver also. Like, so half of the like cost goes into human resources, paying the human driver. So that thing can be dealt very easily. But in India, Nitin Gadkari, the transportation minister, gave a statement that he will not promote any technology that will lead to loss of jobs. So for a company, this will be a very profitable thing. But for a consumer, there will be a lot of loss of jobs. Ola, let's say Ola has around 10,000 drivers deployed in vehicles all across India. So they will be losing the jobs. So, what are you ready to compromise? It all depends on that. What is the country ready to compromise on? This was a very good question, actually. How do you manage to get investors? We are currently we are bootstrapped. Like we had put in some cash from ourselves. There are a couple of small angels, but currently, because we have not actually gone to investors right now, because we have to be sure, like bring something out, like let the product speak of itself. Instead of saying that we will do it, let's show, okay, we have done something. Now tell me, are you ready to invest or not? So we have not approached investors until now, because we need to really have something on road that can easily convince, instead of begging in front of investor. Better thing is, if your product speaks up for itself, investor should come to you, not and you should go for to investors.
Yes,
So
so true.
we hope so, but yeah, this is a big claim. But yeah, though we have been like accepted into a couple of accelerator programs, like let's say Nvidia and all. Nvidia is kind of sponsoring us in kind, AWSs and all. Yeah, was your simulator stack as Carla is not designed for in-person? We are testing it live on public roads, bro. We are testing it live on public roads. We do not actually, I never use the simulator in my company. Let's
Mm,
simple idea is install the system on a road, drive the vehicle yourself, and input that feed to the software of yours, and now cross check, is your software taking the same decision that a human took that time? You cross check that. That is a better way of evaluating than doing in simulators. Like you may do not control the vehicle by motors, drive the vehicle yourself. You just cross check, did the software take the same decision or not? The first task we did was quite simple. We put a tripod on the motorbike and recorded a video basically of on driving on a road, and then we put that video in a software and try to guess, did we take same decision that I took while driving the vehicle? I think that is a better metric. Reality can't be basically simulated. Reality is a lot more different. As similar to like theoretical knowledge does not work in real life.
yes.
How can we normalize use of autonomous vehicle and bring fear in people away? Okay, sorry. Yeah. So that is something, it's a part of the process. When the first time Henry Ford, let's say, bought car out in the world, people were obnoxious to use that. So it will take time. You can't say that people, that is, that's why there is thing we call marketing, right? Simple. If you use influencer marketing, you use meme marketing, then a lot of things. Best example you have is of Elon Musk. He uses marketing more than technology. His technology might,
Yes.
Tesla might be not that advanced, but the way their market is something really good. Is there need for self-driving cars in India? There is need to decrease the accidents. Number one, uh, currently they like there are around 40% of the people on the road, like 80% of the accidents that happen, they are due to human error. And machine, basically computer will not do self-driving. See, the car, self-driving car will not do rash driving. It will follow rules. It will overtake, like it will, the self-driving car knows that other people will not follow rules, but I have to follow rules. So if there are a full fleet of autonomous vehicle and say every car is driving autonomously, obviously, uh, if there are robotics guy here, you must have already used swarm robotics,
Yes, sir.
controlling like
Yes, sir.
simultaneous five drones together and keeping them in sync. And that syncing is basically something, when everyone follow rules, obviously there will be no accident. And if we are able to reduce, like there are 1 lakh accident in India, let's say, and even if we are able to reduce 20,000 lives. But out of 1 lakh deaths, we are able to decrease those to 80%. That is also a very big thing. Like 20,000 people's life are saved. That is big because human life is invaluable. If you meet with a road accident, ask your parents. They will, you can't, no matter how much money doctors will ask, they will try, try to pay because human life is invaluable. So multiply that infinity with 20,000. Some infinities are greater than other infinities. If
Yes.
you guys have read Fault in Our Stars.
Yes.
Why can't we use Simon's neural network for training? See, this is not why can't we use. There is no why can't anything. Like, see, you have to test the approach and get the results. And there are certain approaches which might work for one task in a very good manner and not for the other task. And you compare the accuracy. Let's say, simple example, I try this model and it gives me, let's say, 80% accuracy, and there is some other model that is giving 81. I will always prefer 81% accuracy model, even if it's just a matter of 1%. So that is the thing, it depends on the use case, your architecture, like what kind of architecture you are using. So in certain scenarios, convolutional neural networks are very good, but in certain cases, convolution plus other like recurrent, a mixture of both is beneficial. It depends what is your architecture, right? The what type of vehicle you are going to use depends on like on the road you are going to travel on. You can't travel on a railway track with a car. You can't travel on road with a
Train.
train. You can't fly in the air with a train. You have to use airplane. So it depends on what the architecture you are using in. Like there is a network of roads, or there is a network of train, or basically rail tracks, or there is open sky. If I say you can't use the architecture you use for self-driving cars and drones, right? Drones have free vision. They do not need to know like it is a car or a human. They have free. They just treat anything as a basically point object and overtake that.
Yes.
So that is the thing. It depends what is your architecture.
I think people are continuously asking questions. Any
Any
further
future
plans?
plans to collaborate with Tesla or Tata Motors? Why would Tesla collaborate with us? But yeah, for Tata, we might collaborate if it things comes feasibly because to basically manufacture electric vehicles, and we might kind of integrate that thing. But the thing, as I said, just a minute, just a minute.
Yes, sir.
Huh. Let's say self-driving car is not a software problem only; it's a both hardware problem. The architecture of your vehicle and all that too has a major role. So that's why I believe we have to build the car from the ground up. So this I can't comment on it right now. Any other question?
So I think questions are over.
Hmm. Finally, sir, we're very glad that we had such a great speaker with us.
It's my pleasure.
There's some
It's my pleasure. It was really great interacting with you all, and there were quite a couple of very good questions also. Really appreciate that. Usually, uh, that was something really nice, like the quality of the questions people asked. So that is something really good.
thank you, sir.
And keep up the good work. This is something, educating people on these type of technologies and all is really vital process in making like more and more. Currently, like this is case like people know दो ही चीजें हैं, मेडिकल कर लो, engineering कर लो. And even in tech also the thing is like that. People know, okay, software engineering do, let's say, let's do web development, app development, or let's say do AI. But in AI there is also like there are very people, less people who have building drones as a passion, or building rockets as a passion, or let's say automobile designing. So making people aware of all these new frontiers, 5G technology is what we call. This is something very important in the education process, and that is like kudos to people like you who are organizing these types of events for the community, right? Because I like you learn more outside the classroom. You never learn
Yes.
in the classroom. You can't apply that knowledge in real life. In the college, whatever you do it to yourself, like whatever you learn on your own, that is something more valuable. So these things are really great initiative.
So it was a whole new experience for us also to like interact with you, like these autonomous cars, to learn about them. It's way very interesting. Thank you so much for being a part of Robo Week
It's my pleasure.
2021. Thank you, sir.
Thank you, sir.
Okay,
Thank you.
bye.
Bye, bye, sir.